Okay. We're going to have operations with polynomials. Okay, there's probably all kinds of explaining I could do prior to this, but we're going to just jump in. Determine whether this is a polynomial. Poly means many, like terms. The only thing about these terms is, and I'm kind of like here we got, oh dear, here we got c to the fourth power. That's okay. But look at here, I have -4 times square root c. This is not to the second power, it's not to the third power, it's not to the fourth power. This is okay. So anything you have like a power, like a second power, a third power, a fourth power, we're great. If you have negative powers, we're not so great because that flips to the bottom and then we no longer consider the variables in the denominator as part of our polynomial. So if this said, if it is a polynomial, state the degree. No, we're not even saying it's a polynomial. Okay, let's go into this one. This one, we have -16p to the fifth. We're good. P squared, q squared. Those are in the numerator, in theory, because they're actually over 1. You can have numbers in the denominator. That's okay. So this is a polynomial. We have to state the degree of the polynomial. All right? The degree is basically your highest exponent. But here's the kicker. We need to look at each term separately. So what is the exponent here? 5. So basically the degree of this little term is 5. And here you might be like, hey, 2, 7, what do I write? You know, well, you actually add them up. So 2 and 7 together is 9. So this portion has a degree of 9. This portion has a degree of 5. Well, what's the overall degree of the polynomial? Which one wins? 9. Okay? And so yes, this is a polynomial. The degree is 9. Is 1/2 a squared b cubed plus 3c to the fifth a polynomial? We're going to say yes, because our powers are all positive. There's nothing in the denominator. We don't have square roots, no negative exponents. So now I look at the degree of each part. This has a degree of 5. This has a degree of 5. So what's the degree of the polynomial? Well, you could battle out who's going to win, 5 or 5. It's going to be a tie. So your degree is equal to 5. Square root c plus 2. Well, that square root makes it not a polynomial. No way. So we don't have to state the degree. All right. Now we're going to do simplified. This is stuff you did in Algebra 1. It should come back to you pretty easily. This is probably not one of the more challenging lessons we have in here. But let's just quick go through this. My biggest thing and the biggest mistake that's going to happen, I foresee, is this negative. When you have a negative in front of a parenthesis, it's like taking a -1 in front of a parenthesis. Okay, so you can take -1 times this, -1 times that, -1 times that as well. So what does that mean? I rewrite this the way I see it. And now I'm going to have a negative a cubed, or I can write -1a cubed. A negative times a negative is positive 3a. -1 times 2 is -2. If you're really sneaky, I like to just think switch, switch, switch my signs. This is positive, it becomes negative. This is negative, it becomes positive. This is positive, it becomes negative. Okay, now we combine like terms. 2a cubed minus a cubed. Well, remember, this is like a 1. We don't write it. 2a cubed minus 1a cubed is just a cubed. Combine 5a and 3a. We have 8a. Combine -7 and -2. We get -9. Okay? Example 6. Oh, now this one's a lot nicer in the sense that we have a plus. We don't have to switch any signs. So really, I don't have to do any math before I do my combining of like terms. So I have 4x squared, -2x squared. Well, that's 2x squared. -9x combines with -5x. That's -14x. And 3 and -6 gives me -3. Okie dokie? Okie dokie. Example 7. Oh, I've got that minus in there again. So I have to take -1 times everything in this parenthesis. I'm going to rewrite so you can see it. So now I have -4x squared I have negative 1 times x, I have negative x. Negative 1 times negative 5 is plus 5. All right, combine like terms. I have negative 1x squared. Those are gone. I have a 2x minus x, which is x. And then I have negative 3 and positive 5, which gives me plus 2. Negative x squared plus x plus 2. Okay, we have another one. I'll show you again because this is a common mistake, is that I see kids not multiplying everything by negative 1, or we just forget. I don't know, we have various things that happen. So I'm going to take negative 1 times 4x squared, or I'm just going to have, switching the sign, negative 4x squared. If you want to go this way, I'm taking negative 1 times this, or I switch the sign to negative x. Negative times negative is positive, or you switch the sign to a positive 5. Oh, once again, I pointed with my finger, not so helpful. All right, negative 3x squared, negative 4x squared is negative 7x squared. Negative 4x, negative x is negative 5x. 1 plus 5 is 6. There's your polynomial. Okay, on number 9. This is distributive property. You're taking negative 1 times everything in the parentheses. Or not, did I say negative 1? I meant negative y, if I didn't say that. Negative y times 4y squared is negative 4y cubed. There's actually a 1 for my exponent. When you're multiplying with like bases, you add your exponents. Negative y times 2y is negative 2y squared. Negative y times negative 3 is positive 3y. Okay, it's basically fancy distributive property. Here we go again, same kind of thing. Negative x times 2x cubed is negative 2x to the 4th power. Negative x is plus 2x squared. Negative x times 5 is negative 5x. Example 11. Okay, the book is setting them up like this. That's fine. You might send your ACTs, MCAs, what other lettered tests you might be taking. But what I'm going to suggest we do, and this is like extended distributive property, I'm going to switch this around. And I can do that because isn't 3 times 4 the same as 4 times 3? So if I write this times this, it's the same as saying a plus 2 times a squared plus 3a minus 4. This is just, you know, multiplication, but just of polynomials. So it works this way. And I think every kid is going to like this better. It works the other way as well, but here we go. First I'm going to use this purple here. I'm going to take a times everything in the parentheses over here. Then I take 2 times everything in the parentheses over here, because I got to be fair if I'm distributing. Yeah, this is you're gonna need space along your paper to go from the left to the right. A times a squared, a cubed. A times 3a, positive 3a squared. A times negative 4, negative 4a. 2 times a squared is positive 2a squared. 2 times 3a is 6a. 2 times negative 4 is negative 8. Now I combine like terms. A cubed. And please try to write things in what we call descending order, meaning start with your highest exponents and work your way down. So a to the third is my highest exponent, so I have a to the third. Nothing combines with it. I'm going to cross it off so I hope not to get as confused. I've got 3a squared, 2a squared. 5a squared. Okay. Negative 4a, positive 6a. That's going to be just a plain old 2a. And then minus 8 says, I don't have anybody to join me, but I'll come down and join the polynomial anyway. There you go. Example 12. Kind of just like the other one, just different numbers. Once again, you could take x times everything in the parentheses and then take 4 times if you want to do that. But I just think in general, most of us are going to like to see it this way. Okay, so it's probably worth your time to do that. All right, I'm taking x times x squared. x cubed. X times 3x plus 3x squared. X times negative 2, negative 2x. 4 times x squared is 4x squared. 4 times 3x is 12x. 4 times negative 2, negative 8. Combine like terms, x cubed comes next. I don't have any, oh here I do. 3x squared and 4x squared is 7x squared. Negative 2x and 12x is 10x. And then we have minus 8. I just have to take a quick peek. Is that the exact same problem I just did? No, because I knew it ended with 8. All right, and that's the end of our lesson for the day.